Every smart contract platform makes a choice about what the world gets to see. Midnight's model is built around private computation, public transcripts, zero-knowledge proofs, and verifier keys. A language for that model cannot treat privacy as an add-on. This is Compact, Midnight's smart contract language, where privacy isn't a feature you import. It's the starting point. On most public platforms, everything starts visible. Data, logic, inputs, outputs. Smart contracts run on-chain as programs, and the network verifies execution by rerunning the public computation. That model is well established, but it starts from public visibility, and everything else has to be retrofitted around that fact. You can extend a language like Solidity with a privacy library, but now the developer is juggling two mental models at once: the public smart contract model and a privacy model layered on top. Midnight starts from a different premise. Privacy-preserving contracts are not public contracts with an extra privacy layer attached. The model separates what can be public from what should remain private, and uses zero-knowledge proofs to connect the two sides. That difference changes what the language needs to express. The most important shift is that Compact treats circuits as first-class citizens. When you write a Midnight smart contract, your interaction splits into three parts: a local part that runs on your machine, a ledger part that records public state, and a circuit part. The rules that connect the two. The blockchain does not need to see your private inputs to validate the interaction. It needs a zero-knowledge proof that the rules were followed, and a public transcript it can apply to the ledger state. Compact exists to describe those rules. The compiler doesn't just output application logic, it outputs the zero-knowledge circuits that prove each interaction followed them. The circuit is not a side artifact. It is one of the central objects the language expresses. Compact is a language for defining what must be proven, not merely for writing code that runs on-chain. Once proofs are central, the language has to show you where every value lives. Compact separates the environments directly in the language, with three constructs: ledger, public state that belongs to the on-chain contract, circuit, logic that participates in proof generation, the rules validators check, and witness, off-chain functions that run on the user's machine. Witnesses can retrieve private state, but they can do more than that. They can run computation that isn't feasible or supported on-chain, like division, and the contract verifies the result in circuit. On-chain verification of off-chain compute, without explicit boundaries, developers lose track of where a value lives, who can see it, and what they must prove about it. In a privacy-preserving application, that is exactly the mistake you cannot afford. Privacy-preserving systems still need disclosure. A payment must show it's valid. A compliance workflow must reveal one fact to one authorized party. A game may publish a score while keeping the player's input private. The question is never whether anything becomes public. It's who sees what and when. Compact enforces that with a single keyword: disclose. Values only become public when they cross a visibility boundary: a ledger write, a return from an exported circuit, or a call into another contract. If a witness-derived value reaches one of those boundaries without a disclose wrapper, the compiler rejects the program. Not a warning, a rejection. A private value cannot become public by accident. Privacy is the default. Disclosure is a deliberate, visible choice, written in the code, where everyone can see it. So why a whole language rather than a library? Because flexibility is not the same as clarity. When privacy boundaries, proof logic, and ledger state are core to the model, developers shouldn't have to infer them from a library call buried inside public execution logic. A domain-specific language surfaces the important concepts at the right level. And Compact keeps a TypeScript-like surface, so you don't need to be a cryptographer to read it, while the privacy structure stays visible in the shape of the code. Compact draws a boundary. An EVM-style contract starts from one question: what does this execute on-chain? A Midnight contract starts from three: what must be public? What can remain private? And what proof shows the transition is valid? Compact is the language layer built around that second framing. Not a syntax choice, a design boundary. If you're going to build applications where privacy actually holds, the language you write them in has to take privacy as seriously as you do. Compact is that language. Learn more at midnight.network.